Welcome back to AI.Code.Cast. Today we're diving deep into a classic coding problem, one that really puts your knowledge of algorithms and data structures to the test.
Oh, yeah.
We're going to figure out how to find the second highest salary in a data set.
It's a problem you might run into in real-life situations,
Oh, for sure.
Like if you were analyzing employee records or figuring out high scores in a game.
Exactly. It sounds simple on the surface, but there are some hidden complexities.
Definitely.
So let's imagine we've got this database table. We'll call it employee.
Right.
It has columns for IDE and salary. Our mission, should we choose to accept it, is to find the second highest salary.
Okay. Sounds good.
So where do we even begin with something like this?
Well, the first thing that pops into my head is sorting, right?
Yeah.
You just sort all the salaries, highest to lowest,
Uh-huh.
and then you simply pick the second one from the top.
That seems pretty intuitive.
Yeah.
But is that always the best way to go about it?
Well, the thing is, sorting can be quite computationally expensive, especially if you're dealing with a massive data set.
I
So
see.
you can imagine it's like trying to organize a library with millions of books by hand.
Right.
It's going to take forever.
So efficiency is a potential pitfall.
Yep.
Are there any other tricky situations we should watch out for?
Absolutely.
Like, what if we have duplicate salaries?
Exactly. Great point.
Like, let's say our highest salary is $100,000.
Okay.
And we have 5 employees making that much.
Uh-huh.
If we just grab the second salary after sorting,
Yeah.
we'll end up with another $100,000, which isn't really the second highest distinct salary.
Exactly. That's not what we want.
So duplicates are definitely something to keep in mind.
Absolutely.
What about those cases where there's only one employee in the data set?
Another excellent point.
Would our solution still work in that scenario?
Well, in that case, you don't really have a second highest salary, right?
Right.
Ideally, our solution should handle this gracefully, maybe return a null value or an error message.
Yeah, that makes sense. We need to consider those edge cases.
For sure.
All right. So we've identified some potential issues with the simple sorting approach.
Okay.
We have efficiency concerns, the issue of duplicates, and what to do when we don't actually have a second highest salary.
Right.
So let's explore some more sophisticated solutions.
Right.
I know SQL is a popular choice for working with databases.
It is.
So how could we tackle this problem using SQL?
Well, SQL has some very useful tools for this kind of thing.
Okay.
One way is to use the limit and offset clauses.
Oh, interesting. I've heard of those.
It's basically like saying to the database, hey, give me the top 2 salaries,
Yeah.
and then just show me the second one.
So we're not sorting the entire data set.
No.
We're just cleverly asking for the top 2 and then picking the second.
Exactly. It's a much more efficient approach.
Can you give me an idea of what that SQL query would look like?
Sure, it would start with selecting the salary column.
Okay.
We might give it an alias like second highest salary, just to be clear. Then we'd order the results by salary in descending order, so the highest ones come first.
Got it.
Finally, we'd use limit 1 offset 1.
What does that do exactly?
Limit 1 tells it to only give us one result,
Uh-huh.
and offset 1 says to skip the very first row, which is the highest salary.
Oh, that makes sense.
Yeah,
So we get the second one,
exactly.
but what about duplicates?
Oh, you're already a step ahead. That's where the distinct keyword comes in.
Right.
We would add that to our query to make sure we're only selecting unique salaries.
I see. So we're only interested in distinct values, not multiple instances of the same salary.
Precisely.
This SQL approach, using limit, offset, and distinct, seems pretty neat.
It is.
But I have a feeling there might be situations where it falls short.
Yeah, you're right.
What happens, for example, if there's only one salary in the entire table?
You're thinking about those edge cases again. Good.
Uh-huh.
Well, in that case, there wouldn't be a second highest salary to find.
Right.
The query wouldn't necessarily break, but it would return an empty result.
Ah, so no error message or anything like that.
No, not with this approach.
That's not ideal.
Not really.
We'd want some kind of indication that a second highest salary doesn't exist.
For sure.
So how can we make this SQL query more robust?
Okay, good question.
SQL has a ton of built-in functions, right?
A lot, yeah.
Are there any that can help us handle these special cases?
There are actually a few, like Ifnull and denserank.
Oh, those sound interesting.
They're very powerful.
But before we get too deep into SQL,
Yeah.
what if we wanted to solve this problem using Python?
Oh, switching gears. I like it.
Python is so versatile,
It is.
and it's super popular in the data science world, so it's worth exploring.
Definitely.
How would we approach finding the second highest salary using Python?
One option is to use Python's list manipulation capabilities.
Okay.
We could store all the salaries in a list,
Uh-huh.
sort it in descending order, just like before,
Okay.
and then just grab the second element.
So that's pretty similar to the brute force sorting approach we discussed earlier.
It is similar.
But Python lists are very flexible, right?
Very.
Are there ways to tweak this approach to account for duplicates and those special cases where a second highest salary might not exist?
Definitely. Python gives us a lot of control over how we handle those situations. One way is to use sets.
Oh, sets. Interesting.
So we could convert our list of salaries into a set,
Mhm.
which automatically removes any duplicates.
Right.
Then we could convert that set back to a list, sort it, and grab the second element.
Ah, that's clever. Using sets to ensure we're only dealing with unique values.
Yeah,
But what about that edge case where we only have one salary in the data set?
right. Good
But
point.
how would we handle that in Python?
We can add a simple check before grabbing the second element.
Okay.
We could say, if the length of our sorted list is less than 2,
Mm-hmm.
meaning there's either only one salary or none at all,
Right.
then we return some special value, like maybe megaless1, or none, to indicate that there's no second highest salary.
I see. So it's all about adding those little checks to make our code more robust
Exactly.
and less prone to errors.
Yeah,
I like it.
that's good practice.
But I've also heard that Python has these amazing libraries for data analysis, like Pandas.
Oh, Pandas is great, yeah.
Could we use Pandas to solve this problem in a more efficient or elegant way?
Absolutely. Pandas is like a data scientist's best friend.
Uh-huh. I can imagine.
It has all sorts of built-in functions for manipulating and analyzing data. It's very powerful.
So how would we approach this second highest salary problem using Pandas?
One way would be to leverage its sorting and deduplication capabilities.
Okay, that sounds promising.
Yeah.
So we'd start by loading our salary data into a Pandas DataFrame,
Right?
which is kind of like a supercharged spreadsheet, if I'm understanding correctly.
Yeah, you can think of it that way.
What would we do next?
So, assuming we have a column named salary in our data frame, we would use the sort values function to sort the data frame by that column.
Yeah.
We'd sort it in descending order to put the highest salaries at the top.
So it's similar to our previous approaches,
It is.
but Pandas probably has a more optimized way of handling sorting behind the scenes, right?
Exactly. Pandas is built to work with large data sets.
Uh-huh.
It's very efficient when it comes to sorting.
Okay, good to know.
So once we have our sorted data frame,
Yep.
we can use another Pandas function called drop duplicates.
Oh, I like the sound of that.
It will remove any duplicate salary values, leaving us with only the unique ones.
That sounds very convenient.
It is.
So now we have a data frame with unique salaries, all nicely sorted in descending order.
Exactly.
To find the second highest salary, we just need to grab the value from the second row.
Yeah.
Pandas data frames are like lists.
Yeah.
We can access elements by their position, just like that.
Yeah.
So we would use index 1 to get the second highest salary, since Python uses zero-based indexing.
That's right.
This Pandas approach seems quite streamlined.
It is pretty efficient.
We sort remove duplicates and then simply pick the element we want.
Yeah, it's a nice way to do it.
Are there any potential issues we should be aware of with this method?
It's always a good idea to be cautious.
True.
Similar to our Python list approach,
Okay.
we still need to handle the case where there might not be a second highest salary.
Right, of course.
We can check the length of the data frame after removing duplicates if the length is less than 2.
Yep.
We know we have that edge case to deal with.
Makes sense.
Yeah.
Always good to have those safety checks in place.
Absolutely. You don't want your code to crash unexpectedly.
Exactly.
Now, I'm curious, is there a way to find the second highest salary in Pandas without sorting the entire data frame?
Well, that's an interesting thought.
Because sorting can be a bit time-consuming, especially when dealing with huge data sets.
Right. It would be great to avoid that if possible.
And guess what? Pandas actually has a function just for that.
Really?
It's called Nlargest.
Okay, Nlargest.
Yeah.
That sounds promising. Tell me more.
So with Nlargest, you simply tell it how many of the largest values you want
Uh-huh.
from a specific column.
Okay.
In our case, we would apply Nlargest2 to the salary column.
Got it.
And that would give us the top 2 salaries without sorting the entire data frame.
Wow, that sounds very efficient.
It is. It's a great way to pick out the top N values from a column.
But we still have to deal with duplicates, right?
Right. We can't forget about those.
So how would we combine this Nlargest function with deduplication?
We can simply chain the drop duplicates function before using Nlargest.
Ah, so it would be like a two-step process.
Yeah, in a way.
First, we deduplicate the salary column using drop duplicates.
Yep.
Then we apply Nlargest2 to get the top 2 unique salaries.
Exactly.
And finally, we can grab the second element from the result, which would be our second highest salary.
You got it.
All in one elegant line of Pandas code.
Pretty neat, right?
Very cool. It really shows how powerful these data manipulation libraries can be.
They are incredibly useful for these types of problems.
This deep dive has taken us through a whole range of solutions.
We've covered a lot of ground.
We've explored brute force sorting,
Yeah.
looked at elegant SQL solutions with limit, offset, and distinct. And now we've seen how Python, both on its own and with the help of Pandas, can solve this problem efficiently.
It's great to see different approaches in action, right?
Absolutely. It really highlights the fact that there are often multiple ways to solve a coding problem.
Exactly. There's rarely just one right way.
And understanding the trade-offs of each approach is key to choosing the best tool for the job.
Absolutely. You have to consider the context.
But beyond the specific code itself, I think the real takeaway is the importance of carefully considering those edge cases and potential problems.
Oh, I completely agree.
They often make the difference between a decent solution and a truly great one.
You got it. It's about robustness and making sure your code can handle whatever comes its way.
Precisely.
Now, you mentioned earlier those SQL functions like Ifnull and denserank.
Oh, yeah, we didn't get a chance to explore those fully.
Maybe we should dive back into SQL
I may.
and see how they can help us write even more sophisticated queries.
Sounds good to me. Let's do it. Okay, let's start with Ifnull.
Right?
Can you remind me what it does?
Sure. Think of Ifnull as a backup plan
Okay.
for when your query returns an Ifnull value.
Uh.
So let's say our limit and offset query doesn't find a second highest salary.
Right.
Instead of just getting an empty result,
Yeah.
we can use Ifnull to replace that L with something more helpful.
Like what?
Maybe some text like, no second highest salary found,
Oh.
or a specific number like me_1, just to signal that there's no result.
So it's like telling the database, if you can't find what I'm looking for, give me this instead.
Exactly. It's all about making the output more user-friendly.
That makes a lot of sense.
It's good practice.
What about denserank?
Ugh, that's a powerful one.
It sounds a bit more complex.
It is, but very useful.
So how does it work?
denserank is all about ranking things.
Okay.
Imagine you have a list of all the employee salaries.
Right.
denserank would go through that list and assign a rank to each salary.
Uh-huh.
The highest salary would get rank 1.
Makes sense.
The second highest gets rank 2, and so on.
So it's like creating a leaderboard for salaries.
You got it.
But how does it deal with those duplicate salaries we talked about?
That's the beauty of denserank.
Okay.
It handles ties really well.
Oh, good.
If we have multiple employees with the same salary,
Uh-huh.
they all get the same rank.
So if 3 employees all have the highest salary,
Yep,
they all get ranked as number 1,
exactly.
no matter how many there are.
That's right.
That's very helpful.
Keeps things organized.
How do we actually use denserank to find the second highest salary in SQL?
We would combine it with a subquery.
Okay,
Yeah.
subqueries, I remember those.
Think of it like a mini query inside your main query.
Oh, like a question within a question.
Exactly.
All right, walk me through how we'd use them together.
Sure, first we'd write a subquery that uses denserank to rank all the salaries in our table.
Okay.
This subquery would give us a table with 2 columns, the salary and its rank.
Got it. So the subquery does all the ranking work.
Exactly.
What happens in the main query then?
In our main query, we select the salary from that ranked table,
Yeah.
but only where the rank is equal to 2.
Ah, so we're filtering based on the rank.
Precisely. That's how we pick out the second highest salary.
That's pretty clever.
It's a common technique in SQL.
But wouldn't that be a lot of work for the database to handle, especially with a huge data set?
It's a good question.
All those rankings and subqueries?
But remember,
Yeah.
databases are designed to handle these kinds of operations efficiently.
Right.
And window functions like denserank are pretty performant even with lots of data.
Okay, that's reassuring.
They're built for this kind of thing.
I'm starting to see how powerful these SQL functions can be.
They really expand what you can do with SQL.
This whole deep dive has been fascinating.
I'm glad you're enjoying it.
We started with simple sorting,
Yeah.
then got fancy with SQL using limit, offset, distinct, Ifnull, and now denserank.
Quite a journey through SQL.
And we even explored how to do all this in Python.
Using lists and sets.
And the amazing Pandas library.
It's been a great exploration of different approaches.
It really highlights the fact that there's often more than one way to solve a problem in coding.
Absolutely. And choosing the right approach is a key skill for any developer.
Beyond the code itself, I think the biggest lesson here is the importance of thinking critically about the problem.
Couldn't agree more.
understanding not just the ideal scenario, but all those edge cases
These pesky edge cases,
and potential pitfalls.
they can really trip you up.
It's about making your code bulletproof so it can handle whatever data comes its way.
Exactly, that's the goal.
Well, I think it's time to wrap up this episode of AI.Code.Cast.
All right.
It's given our listeners a lot to think about today.
We have lots of food for thought.
But before we go, here's a final challenge for our listeners.
Okay, a challenge.
What if you needed to find not just the second highest salary, but the third, the 10th, or even the north highest salary?
Ooh, that's a good one.
Where jor could be any number.
That's a great generalization of the problem.
Could you adapt the techniques we discussed today to solve this more general problem?
I think our listeners are up to the challenge.
I bet they are. So give it a try. See what solutions you can come up with.
Keep those coding brains working.
Until next time, keep coding, keep exploring, and keep that curiosity burning bright.